So we're looking at problem number 2 here, and I've already written out kind of everything we need to find. And basically it comes down to, we've got a parallel circuit here with two series branches. So this is a series branch and this is a series branch. And we want to basically turn both of these resistors in each of those series branches of our parallel circuit that's got two branches, like so. And we want to make a circuit with, this will be resistor equivalent 1, and this will be resistor equivalent 2 when we combine them. So we're going to make a new circuit. Here's our battery, 12 volts. And the new circuit's going to look like that. Resistor equivalent 1 and resistor equivalent 2. So I'm just going to shorthand these as 1 and 2 now. Or maybe I'll just say E2 and E1 just to shorten it up. And what I've got to do is I got to add the new new resistance, which since these are in series, I can just add them up. So 10 plus 20 equals 30. We got that. Erase this. Say REQ1 is 30 ohms. And I can put this one on the outside. REQ2 is 40 plus 100, so it's 140 ohms. Okay. So I want to find the total resistance of this circuit. So that's just like resistance total is going to be 1 divided by 1 over RE equivalent 1 plus 1 over R equivalent 2. And this will give us our R total. So we'll start filling in values. 1 divided by 1 over 30 ohms plus 1 divided by 140 ohms. I'll put that in the calculator. Equals R total. So R total for this circuit is going to equal 1 divided by 30 ohms. Oops, that was times. Okay, 1 divided by 30 ohms plus 1 divided by 140 ohms. So we get this number here. I'm actually going to copy it, try to get a more accurate final answer. And then I'm going to do this value 0.04047 dot 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 divided by 1. So 1 divided by this. And our total is going to equal 1 divided by this 24.7. So equals 24.7 ohms. And that's what I'm going to go with. So my resistance total is going to be 24.7 ohms right here. I'm going to fill in all my other given values right now. So 12 volts. And then I got 10 ohms and I got 20 ohms. And this was 30 ohms because they just had to add those up because they were in series. And then I got 40 ohms. And then I got 100 ohms. And when I add these two up, because they're in series, I end up with, what do I end up with? That is a great question. I get 140 ohms. Okay. And then to get the I total equals R total divided by voltage total, I apologize, equals voltage total, V total divided by R total. So I total is 12 volts divided by 24.7 ohms. I total equals, so 12 divided by 24.7 And we're going to go with 0.486. 0.486. So 0.486. Okay, very good. Now, this is where it gets a little bit tricky. So, what things do I know? I know that the total voltage for the series circuits are 12. So like I know that the voltage going into R equivalent 1 and R equivalent 2 are going to be 12 volts. The problem is there's voltage drop within there on these levels. So like I know going in here we've got 12 volts and going in here we got 12 volts. And I can derive current from that. But then I'm going to have to break it down further. So I know that I have basically 12 volts in equivalent 2, and I have 12 volts in equivalent 1. So the good news about that is I can figure out the current in these locations. And once I have the current going into each of these branches, which should add up to the current total of 0.48, then I can use that current to figure out what the voltage drop is at each of these resistors. So let's duplicate this slide and do that. So I'm going to duplicate the slide, and I'm going to slide on over. Okay. So do a little bit of erasing. All right. So where was I? I'm going to figure out the current here and the current here. At each of these locations. So where's my handy dandy calculator? So the current at R equivalent 1 equals the voltage at R equivalent 1, which happens to be the voltage total, divided by R equivalent 1's resistance. So the resistance at equivalent 1. And then I at R equivalent 2 is the same deal. R equivalent 2 divided by the actual R equivalent 2. So if I'm filling in just the values, it'd be 12 volts divided by 30 ohms, boom, boom, and 12 volts divided by 140 ohms, bump, bump. Calculate that. We got 12 divided by 30 can equal 0.4. So I put a 0.4 up there, which means the current in each of these branches is also going to be 0.4. 0.4, which now you can see 2 out of the 3 we can solve that, and 12 volts divided by 140. That's a much smaller number there. We're going to go with 0.086 because when you round it, that gives us our current total when you add this and this up. See this and this, give you this. So that looks like it's going to work. So resistor equivalent 2 is 0.086, which means both of the series values in there are going to be 0.086. Armed with all of this information, I should be able to find out what we got here, 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 and here just using Ohm's law. So the voltage at, let's start with R1 equals I at R1 times R1, which is going to equal 0.4 times 10 ohms. So 0.4 times 10, I think we can all figure this one out, is 4. Great. And then voltage at R2 equals current at R2, which equals 4. Amps. No, that was volts. This is amps. This is amps. This is amps. This is amps. Forgot to put in the amps, everybody. This was volts. So volts times R2. So we get 0.4 times 20 ohms, and that's going to equal 0.4 times, not divided by, times 20 is 8. And look, 4 plus 8 equals 12, so that looks good. 8 volts, cut this off. V at R3 equals current at R3 times R3, which equals, what do we got? 12 times, or no, current R3 is not 12. R3 equals, my current at R3 is 0.086 times 40. It's going to equal some amount of volts, 0.086 times 40. I divided it to 0.086 times 40. Big difference. 3.44 volts, so 3.44 volts. And then voltage at R4 equals I at R4 times R4, which equals 0.086 times 100, which is going to be 0.086 times 100. And we're going to get 0.86 volts, or 8.6 volts, which is not going to quite add up. It's going to be a little over 12, so 3.4 plus 0.8, or 8.6, blowing it, 8.6. So that adds up to 12. So we're a little off there due to rounding issues at some point. So I will round that off so the rounding works out better. Because remember, it wasn't actually 0.086, it was 0.086 and a bunch of numbers when we did the calculation down here. But it's close enough. If you put in like 3.44, that would be acceptable to me. Because these two values do, these two right here, do add up to the 12 volts. So that's everything you would need for this problem. So basically all you do is you turn this into a simple parallel circuit, and then you just come back and figure out the information for these resistors. Okay. And maybe I will come back and make a video for number 3. We shall see. Have a good evening.